Okay, so we left off with the simple example of an object loader. Now, what this object loader does is basically to read what you have in the OBJ file. It doesn't really care about the materials, and it was also very simple because it just read this cube. Of course, you have more complicated structures as well. So, as I mentioned some slides back, you can also divide this file structure into objects, groups. You also have an additional file for material, and you have also something called a smoothing group that has to do about lighting and normal vectors, basically. So I'll talk a little bit about what you mean by an object and a group. Basically, when you have an object, you start your line with an O, and what follows there is basically related to that object. And every object typically has its own material definition, which goes back to the material file. The same goes with group, but then it's usually related to geometry. So objects and groups are sort of similar things because it's about listing whatever thing comes afterwards is textured and has this geometry and is using this and that texture file and so on and so forth. So I can give example on groups now. So I can go back to this sponsor here. Just zoom a little bit now, I think that's about it. So here you see many different geometrical objects, right? So you have arcs, you have pillars, you have those sort of things. And in this particular file, that's exactly what it's divided into. So for example, this is one type of arc. Okay, sorry for that. Anyways, so we have this sponsor, right, with this different, consisting of different groups. So if I go into the OBJ file connected to it, open it in Notepad, for example, I will see that I have a lot of vertices, of course, because it's consisting of 66,000 or something. And if I go down and I look for a G, for example, I will find group arcs on the floor. And use material blah 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 something here that refers back to the material file, which I haven't talked about yet. So basically this is one group, and then I find the next one, for example. Here you have arcs 03. I look this up so I know that arcs on the floor are those ones down here. These other arcs are the ones on top here, and so on and so forth. If you go further down, you could search up a pillar and so on and so forth. If you look at this guy spinning around here, it's known as. If I load that one, it's basically consisting of. Try to have a look at that. Yeah. So here again you see another OBJ file. If you look at the OBJ file connected to this one, you will see that you have this all visor, for example, that's the glasses. If I go further down and look at another O, it's another object called legs, for example, and another object called hands. And to each of those you have connected different materials. And if I load this one inside, put this down, inside this 3D program instead, I can basically look at the mesh, but I can also look at material ID. So you have 6 different materials and they correspond to that object. Yeah.
What's the difference between groups?
It's a bit fuzzy. I think when you talk about group, you're basically talking with respect to geometry. Typically in the math way, you talk about different groups, that different geometries belong to different groups. Here it's more like objects of a figure or something.
But are groups represented in the text file?
Yeah, as a G. If you say G, then what follows is a group, and you have a material connected to it. If it's an O, it means an object, and you have a material connected to it. So it's more or less the same thing that happens, more or less. Yeah.
So the vertices for the arc is only written once, and then you use it again with different offsets? I
think that for these particular groups you have different vertices, because you have I think you can reuse vertices in some cases. But I also, let me check that. I can actually check that because you'll see it in the file. So, Bonza. Yeah, so takes arcs 03 for example. Yeah, maybe you basically use the same one for that. That may be a key here. But I may be... okay, no, we have a set of coordinates here as well, it seems. And by the way, here you see it's written a bit differently than it was on the other file. You have all these coming after the face description, basically. Yeah, I got a bit lost here. Okay, so let's see if I go to V, find next. No, actually, yeah, I think you're right. I think that these two arcs, they use the same set of vertex information, maybe.
Where do you see the offset?
Maybe offset. What offset?
So where do you see the offset of each arc if they're using the same vertex?
Basically, you see here, for example, let me go back to object 32 is one. If I go here, you have G. So here you have arcs of 3, it's the arcs on the second floor, right? And then you have arcs on the floor, basically. So then you have some face description for each of them.
Yeah, but that's just the indices of each face. I mean, what I was if each arc was using the same set of information, but just positioning it.
Yeah, translating it on the world space. Like we make one model.
Can then use it multiple times or just translate.
Like in OpenGL, for example.
Yeah, I understand that what you mean. That you have no. I'm not really sure in this. The arcs are somewhat different, but you may have that. This is basically just a sort of mathematical operations between them. But I do think here that I can look at the structure. I haven't looked deeply enough into this model to know exactly how it is constructed, but I think we may figure it out. So let's go to the example and see. I think so one arc is related to the other through just scaling, rotation, and those sort of things. Said they have different geometrical shapes. So you see one, you see for example the one, these may be the same, right? They're just scaling and translation of the same object, right? But I think the ones they have a slightly different geometry. So this takes a bit of time, sorry. But example. So I'm not sure if it's. I know they use the same texture that you can figure out. I think you have two different groups. You have to treat them differently. So you cannot just translate and rotate and scale. So you see these arcs on the floor here is like a half circle, right? Sort of geometry. So it's not enough to just scale, rotate, and translate them.
But the top ones are alike.
We have multiple of the same arc.
On the top.
And,
oh yeah, you mean the same ones?
Yeah.
Oh yeah, of course. Yeah, sure. That's just the same one being reused. Yeah.
So where do we see the offset in the object find?
No, I wonder here if they just read it. Because if it was just one set of face coordinates, it would probably not be that many. So maybe this is a bit, That's a good question. I haven't really thought about that. But you see there's a myriad of faces. No, not that many actually.
face.
96 polygons, so 96 triangles.
But do the spaces represent just one arc or the whole group of arcs, like the row of them?
I wonder if that this is actually right. This represents one arc, basically.
The face. Yeah.
Yeah.
And how does it put it together?
Yeah, that's a good question. I'm not exactly sure.
All the faces.
Because this has to be. I should dissect this one and see. Let me go here. So here you see the triangles. Oh, it's not that. It's one. It's quite a lot there. On each one you have about 36 faces. That can be right, and you just repeat the same thing. Yeah, it may be.
Maybe what happens if we delete some of the vertices and we see just half triangles everywhere?
Probably, I think that no, they're exactly the same. So I'm sure that they are repeated somehow. I'm not exactly sure why. Yeah, so you see, there's a difference between these ones and these ones, but all these ones are the same, right? So I wonder if it's this may be related to the next lecture, if I'm not mistaken, because this, when you stitch this object together, you usually have what you call a scene graph, right? Which is either a tree or a DAG, basically. And then when you transverse through this thing, you're basically putting object on object on object. So it may be, but it should maybe be part of this file, maybe someplace here. So one thing is for sure, each group here is just one arc, right? That's definitely so. And somehow I think they are, because if you see, if I go to what really? Down. So it takes these arcs on the floor, you have 36. 36 polygons, right? And if you look at this drawing here, I don't think that's 36.
Using 96. So there's 96 polygons on the line.
Did it say 96?
Yeah. It says there.
Oh yeah, 96. Sorry, yeah, I read. Yeah,
polygons.
96. So yeah, but I think that's about what you have on one of them actually. I think you have more than.
So there is like a discount list for each arc?
Yeah, each group is one arc. So there has to be some sort of way of patching them together. Yeah.
And not just repeat it.
Can we get away and achieve the same effect using only objects or only groups? Or is it like a combination of both?
I'm not completely sure.
Because I still don't understand the difference between the group and the...
No, I'm not exactly sure about the difference myself. We could, I think that you can find it in this specification file.
Okay.
So I think group basically is really much related to the geometry of things. So if you have a geometry with many sort of different geometries repeating, you basically call that a group as you would in math with similar geometrical object, right? If it doesn't really have a definition in geometry, like you can look at this room, you have chairs, steps, lights, blackboard. These could be different objects in the room. So I think that's the separation, because when you look at in the file, it seems, and of course groups then would be things that you could move around in this sense probably. An object would be something that you may have just once, like on this nanosuit thing, it may be that the arms are just one set, you cannot really...
So the same groups can be used in different objects?
Yeah, I guess so. Yeah, definitely. I should probably check this up, and I think that this is a very interesting point. I should check this out, and I think it's very much connected to the next lecture, because then we talk about how you patch scenes together by putting them to scene graphs. And I think that that's basically what's lying underneath this as well. I didn't really go much into groups or objects on this one, because we're just going to look at simple object loading. We load a simple object that is quite easily defined, just to get that into your fingers. And then we should basically look at more advanced things later. So I haven't really read myself up on what is what here very neatly. But it's a very interesting thing to know, and it's connected to the next lecture. I'll try to sort this out to the next lecture, and then we can have a little session on that, because I think they are definitely related. So it's a very good point actually. But I can also have a very brief look at the specifications here. If I go to group name G. Okay, I shouldn't probably stand here and read through this because it's going to take a lot of time. But I'll check it out and I will announce it. But you may also read this the specifications if you want to know it sooner than next Thursday. Yeah.
Where was that specification again?
Oh yeah, you'll find a link. You'll find a link on each page here. I have provided a link. So when you go to here, you see more detail. So you have it down on this one.
I was also wondering, in the text box, because it's so long, are we supposed to hard code it, like writing each?
No. I think that the point about these things is when you make when you have a program that makes 3D models for you, right?
Yeah.
They will automatically write into these formats.
Right.
So you don't sit and do that. So that's what's neat about it. And then you just need to load them and start playing around.
And you can also convert the files. For example, if we have like .3, like D3S or what.
Yeah. That I'm not .3ds I don't think because it's binary. It has the same structure but it's binary, so I don't think and it's also a proprietary one, so it's a bit difficult to deal with. And X3D is also more like a markup language type file format. So I'm not sure if you can. I think you can. I think you have the choice in many, like in Maya or in Blender, you have the possibility to save in different formats basically. But I don't think it's easy to convert between them. Because, for example, X3D has much more features than, for example, OBJ has, and they support different features, so there will probably be some collisions if you try to do that. But anyway, instead of me reading this now, I will update myself on it and come back to it. I think for Tuesday's lab, you're going to deal with more or less reading quite simple vertices, and you wouldn't need to know by now exactly how you do that. So, but for later, it's really important. I can just take a very brief look at the file at the bottom if I find some sort of reference to any sort of scene graph or whatever. It's basically just a bunch of groups defined here. I can't see anything in here. So it may be that there is something in here. Yeah, by the way, I'll skip on and leave that open for now and get back to it. So I'll be able to get through the rest. All right. So yeah, let me see if the stream is running. This is hopeless.